In question 12, we are asked to use the graph of the function to graph its inverse. Primarily what I'm asking you to remember is that if we're going to graph inverse functions, when I give you a graph, take some ordered pairs off of this graph, take the xy ordered pairs from this graph, and then convert them so that you can do, let's say we find the inverse function. We're not actually going to find the rule, but those inverse function ordered pairs get turned into y comma x. So find some ordered pairs of your original, then go ahead and graph them by turning them around to find your inverse function. There are some other principles here that I want you to remember, or at least to latch onto. First of all, whenever we graph inverse functions, they have to be symmetrical about the line y equals x. So this is my attempt to get the line y equals x as my line of reflection. Inverses must be reflection about that and match. The second principle here that, or I want to call your attention to, is our original graph has a horizontal asymptote. So that means we have all of these x values that can't be touched. There's no way our original graph touches the x-axis, which means if we flip the roles of x and y, then there's no way that our inverse function will be able to touch the y-axis since the roles of x's and y's get flipped. So it's always important to think about, does my graph, my original graph, have any asymptotic behavior? If it does, make sure you switch the roles of them. Horizontal asymptotes will become vertical, and vertical will become horizontal. So I've got the vertical asymptote there. As a representation, my inverse function should never cross that. Now I'm going to go about finding some ordered pairs that I can graph and turn around. On the original graph, this looks like a pretty good ordered pair. That ordered pair of 0, 4. When we put in a 0, so I don't know the best way to organize it, I'll go x and y. When I put in a 0, we got 1/2 to the 0 power. I'll get something so you can see here. 1/2 raised to the 0 times 4. Anything to the 0 power is equal to 1, so 4 times 1 is 4, so it looks like that was pretty accurate. When you put in a 0, we get a 4. So when we think about graphing our inverse function, we have to make sure that we have an xy ordered pair of 4, 0. So 4, 0 is going to be on our graph. There is the inverse ordered pair of 0, 4. Another ordered pair that looks like it's fairly decent, well, I'm going to put in a 1. I'm going to put in a 1 for x. That means I'm going to have 4 times 1/2 raised to the first. And half to the first is a half, so 4 times a half is 2. So I get an output of 2. So that means when I put in a 1, I get a 2. That means the ordered pair 2, 1 is on my inverse graph. So I'm going to graph 2, 1. I need some more ordered pairs here to help me define the shape of this. So the next one I'm going to do is I'm going to try putting in a 2. So I'm going to put in a 2, see when I get back out for an output. So I'm going to put in a 2, and when I put in a 2, it's 4 times 1/2 squared. A half squared is 1/4, so it's 4 times 1/4, and it's going to give me an output of 1. So when I put in a 2, I get a 1, so that means I graph the ordered pair 1, 2. So the inverse function has the ordered pair 1, 2. Now it looks like it's right on top of that same graph, and this was not my original. That's the point that I turned into 4, 0. Keep in mind that our graph can never touch the red graph. I'm going to grab one other point on here that ends up being a pretty nice point. And the ordered pair 1, -1, 8 on my original graph looks like it's a pretty darn good point. So I'm going to try that one. I'm going to put in a -1, so it's going to be 4 times 1/2 raised to -1. A negative exponent, remember, flips your base, so it's going to be 2 raised to the first, and 2 raised to the first is 2, and 2 times 4 is 8. So what that does, it gives me an ordered pair of -1. Try that again. When I put in a -1, I got an 8, so my inverse should be 8, -1. So that's going to take me off my graph a little bit. I wish I could have shrunk that down. Well, I'll do my best. It's going to be down in here somewhere. Okay, so I know that my graph has got to be symmetrical to the line y equals x. Make it so it stands out a little bit more. And I got to hit the points that I have, and then it's got to come close to my vertical asymptote. That is a pretty good replicate of your inverse function by graphing by flipping ordered pairs. And pay attention to horizontal and vertical asymptotes. Those are important.